Okay, so organic compounds come from fossil fuels. Fossil fuels are a type of fossil fuel is crude oil. And within crude oil, we have a whole mixture of different kind of hydrocarbons. Hydrocarbons being carbons and hydrogen only, no bromine or no oxygen. And so if I have a hydrocarbon that has all single bonds, that particular group of hydrocarbons is going to be called an alkane. And so these are homologous series that we're going to name one at a time. A homologous series is a type of group, and the first one we're going to name are alkanes. So how do I know if it's an alkane in order to be able to name it like the alkane rules? Well, first of all, if I'm looking at the structure, it'll have all single bonds. Second of all, if I'm looking at the molecular formula, it follows this rule, this general formula of CnH2n plus 2. So for example, C3 would be H2 times 3 plus 2, so C3H8. Super handy when it's C50, H102, and you know right away that it's an alkane because it fits that general formula. Therefore, it'll have all single bonds, and then we can name it according to our alkane rules. So the next bit is going to be about our very first organic compound nomenclature, which is a nice way of saying naming. Okay, the first thing about naming alkanes or all organic compounds is you have to have this list memorized. There are more names after C10, but you don't have to have those ones memorized. Just that one is going to be meth. Whenever you see meth anywhere, it's, well, never mind. Anyway, whenever you see the word meth in an organic compound situation, it's going to mean that there's one carbon. And eth is 2 carbons and prop is 3 carbons. Okay, so let's see if you already know this, but like an organic compound like ethane that you had to memorize in Science 10 or whatever, you would have memorized ethane is C2H6. Now, first of all, eth has 2 carbons. Oh, look at that. And ane means it's an alkane and follows the general formula CnH2n plus 2. So C2H2 times 2 plus 2 is 6. So eth for 2, ane for this general formula, and I end up with that organic compound that you had to memorize, right? Same with propane. So prop meaning 3 carbons, ane meaning an alkane, and so C3H, well, 2N plus 2 would make that 6, 7, 8. So C3H8 is propane, as in like a propane tank for your barbecue or whatever. Butane for like butane lighters, pentane. So these are weird, these first 4, meth, eth, prop, and bute. They're like these weird organic names. Monkeys eat peanut butter is how often students memorize it. Monkeys eat peanut butter. But sometimes I had a student once that made up a song. It was the methyl ethyl propyl butyl song. He brought in his ukulele. He's like, I'm going to play this song for you. It's so beautiful. I made it up. Can I play it for you in the class? And I'm like, sure, great. What a great idea. It'll help, to help him memorize. And I said, what's your song called? And he said, it's called the methyl ethyl propyl butyl song. And I'm like, well, if that's the name, then you already have it memorized and you don't need to sing the song. And he's like, oh yeah. So he like put his ukulele down to the side and I never actually got to hear the song ever. And I'm like, anyway. Okay, so methyl ethyl propyl butyl. And then you've got pent, as in like, so from here on in, it's like math, number of sides, concept. So math, 5, pent, hex 6, hept 7, oct 8, non 9, and dec 10. Okay. So when you're naming alkanes, there's these certain rules that you have to follow when they're a little bit more complicated than just these nice little simple ones. We're going to find and name our longest parent chain. Then we're going to number that chain because you can go forwards or backwards when you're numbering. And then you're going to name and number the branches that might be hanging off of this chain. So let's go through some examples of that. Okay, so naming, these are right from your notes. Naming the parent chain, the longest parent chain. So this one's kind of easy. This is sort of still talking about like the ones that we just did. And so here I can see that there's 1, 2, 3, 4 carbons. Remember, every carbon has 4 bonding electrons, so they should have 4 sticks coming off of every carbon. And every hydrogen should only have 1 stick coming off of it because it only has 1 bonding electron. So I can see that I have 4 carbons here. So the way I say 4 in organic chemistry is bute. So bute is what I write down. I don't know if you can see that actually. Maybe I'll pick a different color. So bute is what I write down. And then after that, I can see that I have all single bonds between the carbons. And because it's all single bonds, or because I know it follows the formula, I could count them all, C4H10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C4H10. Both of those reasons tell me it's an alkane, and so it's going to end in ANE. So bute for 4 carbons, ane for single bonds. So it's like it's learning another language here. I'm just saying there are 4 carbons. They are all singly bonded together, and I've filled in the rest of my bonding electrons with hydrogens. That's what it's saying. Okay, so next I have a line diagram here. In this line diagram, remember every bend and every end is a carbon, and then you have the appropriate number of hydrogens for that carbon. So I have as many hydrogens as I need to in order to make my 4 sticks. That's what that's saying. So here's a line diagram. This is telling me that I have a carbon here, 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 and a carbon there, and the appropriate number of hydrogens. So this only has 1 stick, so it must have 1, 2, 3 hydrogens hanging off of it. This has 2 sticks, so it has 2 hydrogens. 2 sticks, 2 hydrogens, 2 sticks, 2 hydrogens, 2 hydrogens, 1 hydrogen, 3 hydrogens, and 3 hydrogens, like that. Okay. So the first thing I'm supposed to do is find my longest parent chain. So what this is like is you kind of have to think of it like a bracelet or a necklace chain. And so here's my longest chain. There's my necklace. There it is there. Okay, there's my necklace. And then I have a charm hanging off of that necklace. So it's like I've gone and bought a charm and I've hooked it on to this second carbon there. Okay. So first of all, how long is my chain? 1, 2, 3, 4, 5, 6, 7. It is 7 carbons long. How do I say 7 in organic chemistry? I say hept. So I'm going to say the longest chain is 7 carbons, and they are all singly bonded. 7 carbons, singly bonded. Then I want to talk about this charm that I have hooked onto my chain. So it's not really called a charm, it's really called a branch. It'd be awesome if that was called the trunk of a tree, and then it'd be like the branch hanging off the trunk of the tree. But they haven't given me a nice analogy, they've given me 2 mixed analogies. So a chain and a branch. Okay, so how many carbons is in my charm, in my branch? I have 1 carbon in my charm. How do I say 1 in organic chemistry? I say meth. So this is a meth carbon. But I also have to tell everybody that it's a charm and not part of the entire parent chain. And so I'm going to call this meth YL. If it ends in YL, it's a branch. So branches end in YL. So this is going to be meth YL heptane. I run out of space here. Hold on a minute. Meth YL heptane. Okay. The other thing you have to tell the reader is, so I have a chain that's singly bonded carbons, 7 carbons long. There's my chain, 7 carbons long, singly bonded. So 7 carbons, singly bonded. This says I have a charm hanging off that's only 1 carbon big. Now that charm could be connected to the second link in my bracelet, or maybe unhook that, stick it onto the third link, you know, the circles, the loops in a chain, the holes in a chain. I could have clipped it onto the third. I could have clipped it onto the 4th carbon. So I also need to tell the reader that I have clipped it onto the second carbon. So 1, 2. So this is going to be 2-methyl heptane. Okay? Because I'm going to number these carbons. I'm going to number these carbons. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. So this becomes 2-methylheptane. Okay, let's do another one. This one is like a hybrid between a line diagram and a display diagram, or structural. I guess this is structural. And so I'm just going to kind of fill it in by saying, hey, there must also be a carbon here, and 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 a carbon here. Every bend and every end has a carbon with the appropriate amount of hydrogens to make 4 sticks. So 3 hydrogens here, 2 hydrogens here, 2 hydrogens here. How many hydrogens there? Just 1, because there's already 3 sticks. Okay, so my first job is to find and name my longest parent chain. So I'm going to use my pink for my longest parent chain again. And I'm going to go, okay, I could go this way. I could go this way for my parent chain. So I'm going to count to see which way is longer, because it says longest parent chain, right? Longest. Okay, so 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5. Okay. Or even 1, 2, 3, 4, 5, 6. Oh, so that's still okay too. Because if like no trunk of the tree is like perfectly straight, they kind of like bend too. It's just about the thickest part is the trunk. And so it's sort of the same idea here, how the longest chain could bend if I wanted it to, or it could go straight if I wanted it to. Okay, so this one is, I'm going to write like this is my longest parent chain here. That's my chain. That's the trunk of the tree. Okay, 1, 2, 3, 4, 5, 6 carbons. So how do I say 6? Hex. So there are 6 carbons in my parent chain, and that parent chain is all singly bonded carbons. I don't see any 2 sticks, and I don't see any double sticks, right? If it looked like that, that would be a double bond. But I don't have 2 sticks in between carbons. I only have 1 stick. So all singly bonded. So I'm going to end it in ane because it must be an alkane. Hexane. 6 carbons singly bonded in my parent chain. Now I'm going to talk about the branches. So this branch here, that charm that I would have bought, I linked it on. That charm I would have bought, I linked it on to the second carbon. This charm has 1 carbon in it. How do I say 1? Meth. How do I say a branch? YL. So that's methyl. This is also methyl. Meth, because it's 1 carbon. YL. These are hooked on to carbon number 2, right? So this is carbon number 1. Here's carbon number 2. So they're hooked on to carbon number 2. So meth YL. So this is going to be a 2-methyl, and this is also going to be a 2-methyl. And this one is going to be, I have 2 carbons here. How do I say 2 carbons? F. And how do I say that it's a charm? YL. So ethyl. This ethyl is off of carbon 3. So now I'm going to put this all together in one name here, okay? This is going to be called, and you're supposed to do this all in one word, but I kind of like run out of space here, hey? CH3 methyl. Okay, all right, you guys all remember that's a methyl. I'll kind of just do that. Okay, right. So naming my branches now, I have 2-methyl and another 2-methyl and an ethyl. Now, one of the rules that I haven't written down on the board, but it's in your notes, is if I have 2 different types of branches, I have to name them alphabetically. Okay, alphabetically. So E comes before M. So the ethyl gets written down first on my naming line here. So this is going to be 3-ethyl. Awesome. Now it's time to take care of the methyls. -2, 2, because I have 1 on 2 and 1 on 2. And because I have 2 of them, I'm going to say dimethyl. And then hexane. I kind of just ran out of space, but whatever, you know. Okay, so the name of this compound then is 3-methyl, 3-ethyl 2,2-dimethyl hexane. 3-ethyl 2,2-dimethyl hexane. So first of all, I had to name them alphabetically. E comes before M. Second of all, if I have 2 branches that are the same, I'm going to put a dimethyl. If I had 3 branches, I would put a trimethyl. If I have 4 branches, I put a tetramethyl. Okay, so dis, tris, and tetras. Now this is seeming like a lot of rules right now and a lot of naming, and maybe you're feeling a little bit overwhelmed at this point, but I can assure you that this part is the beginning of how we name everything in this unit. So you're not going to have to learn any more. Dis, tris, tetras, that's going to apply to every single type of compound that we name. Eth, meth, pro, but. We're going to apply that to every single one. So right now it seems like a lot of vocabulary, but because we continuously use it throughout the unit, you're going to feel like that confidence just keeps building and building as we go throughout this, this unit. Okay, right. Now, the other thing I want to point out about this compound is I decided to number it 1, 2, 3, 4, 5, 6. That black numbering system, but I also in organic chemistry, I'm allowed to number them right to left. That could have been carbon 1. That could have been carbon 2. This could have been carbon 3 and 4 and 5 and 6. So how do you know if the black numbering system is correct or the green numbering system is correct? How am I supposed to go left to right or right to left? So this is how you're going to figure that out. You're going to take your fingers and you're going to put them on the end carbons, and it's like a little game. This carbon wants to be carbon 1 and this carbon wants to be carbon 1. And the person that gets to win this game is whoever hits a branch first. So I want to be carbon 1. I want to be carbon 1. Well, I don't have a branch on me, neither do I. Okay, let's keep going. If I'm carbon 1, he gets to be carbon 2. I want to be carbon 2. Well, do you have a branch? Yes, I have a branch. Oh, shoot, I lose. So that means this guy gets to win because he hit a branch first. So let's do that. No branch, branch. So that guy wins the numbering system. So I'm going to go this way for my numbering system. Okay, we're going to practice that. We'll do it on this one too. Okay, so find my longest parent chain, right? I'm going to think it's going to go straight across. It's going to be my first gut instinct, except for actually, look, this is my longest parent chain. Okay, that's the longest straight line. It's not straight, but anyway, it's the longest line. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons in this longest line. How do I say 9 in organic chemistry? Non. How do I say that all of those carbons are singly bonded? Ane. So I'm going to end in non-ane. I do have branches. Here's a branch, here's a branch, and here's a branch. Those are all methyls. 1 carbon, 1 carbon, 1 carbon. Okay, so how many methyls do I have? I have 1, 2, 3 methyls. So that would be trimethyl. Okay, trimethyl. So 3 carbons. Now we're going to play the numbering system again, right? The black direction, this wants to be carbon 1, this wants to be carbon 2, this wants to be carbon 3, this wants to be carbon 4, 5, 6, 7, 8, 9. Or do I follow the green pathway? I want to be carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So who gets to win, the black pathway or the green pathway? Well, the numbering system that wins out is the direction that hits the branch first. So have I hit a branch yet? No. Have I hit a branch yet? No. Have I hit a branch yet? Ooh, tied. Have I hit a branch yet? No. Have I hit a branch yet? Ooh, tied. They're tied. It's completely the same. If I go the black route or the green route, I'm still going to get 3 or 3, right? 3, 7, and 5. So 3, trimethylnonane. Here, numbering it left, right, or right to left didn't make any difference as to who hit a branch first. It was the same branches the whole way. I hit one, okay, it's a tie. Okay, let's keep going. Oh, we hit another one. Okay, it's a tie. So it doesn't matter which numbering system you follow for that one. Okay, let's go down here. We have we have to find the longest parent chain. First of all, just looking at this little intersection here, I can see that the longest parent chain is not going to go up or out, but it's going to go down because I have 2 carbons there and not just the one. So here's going to be my longest parent chain so far. Okay, carbon, carbon, carbon. And then I'm going to go this way, carbon, and I can choose to go down, up, or to the right. This would be 2 carbons, this would be 2 carbons, but that pathway gives me 3 carbons. So this is going to be my longest parent chain there. It's going to go like this. Okay. All right, so how many carbons in that? 1, 2, 3, 4, 5, 6, 7. So how do I say 7 in organic chemistry? I say, and I'm just going to erase this so that I've got some space here to name it, okay? So how do I say 7? I say hept. Well, board markers are not doing so well today, hey? Okay, how do I say 7? I say hept. All singly bonded, ane. So my parent chain, the longest parent chain is 7 carbons long, and they're all singly bonded. In terms of branches here, I have a methyl, I have another methyl, and this guy is an ethyl, 2 carbons together, and this guy is also an ethyl, 2 carbons together. So now I got to figure out my numbering system. I want to be carbon 1, I want to be carbon 1. Whoever hits a branch first wins. So no branch, no branch, no branch, oh branch. This guy hit a branch first. So this guy is going to be my carbon numbering system. 1, 2, 3, 4. Okay. So this is going to be the 2 methyls are on carbon 3 and the ethyls on carbon 4. So who gets numbered or named first, written down first, is my ethyls because the alphabetical. So this is going to be 4, 4 dash diethyl dash 3, 3 dash dimethyl, and then that heptane gets to keep. In terms of like, don't worry about your commas and dashes really until you get to university. But if you want to be like really correct, it is a comma in between numbers, and it is a dash in between a number and a letter. And then everything else is all one word. So dimethyl heptane is all one word. There isn't a space there. Okay, and as well, like no capitals in chemicals, right? Okay, last one. So here we have a longest chain. It's going to go, first of all, this way for sure, right? Not down, so I'm going to go right. Now I have a choice to go up or right. And if I go up, I hit 2 carbons. If I go right, I hit 2 carbons. So it doesn't really matter. So 1, 2, 3, 4, 5, 6. So there's a hexane for my longest parent chain. Then in terms of my branches, I have a methyl here, and I have an ethyl here. And to figure out my numbering system, do I hit a branch yet? Do I hit a branch yet? Do I hit a branch yet? Yes. They both have hit a branch. There's a tie here. I want to be carbon 1. I want to be carbon 1. No branch, no branch. Ooh, branch. They both have hit a branch on carbon 3. So who gets to be carbon 3, this guy or this guy? Well, the rules say that if there's a tie for the longest, or for a branch, and they're not the same branch, this one's an ethyl, this one, here we had a tie, but they were the same, all methyls. So there's a tie here, but this guy has a methyl and this guy has an ethyl. The alphabet trumps again. So this guy gets to be the winner because his branch has a lower letter in the alphabet. So carbon 1, carbon 2, carbon 3, because I hit a branch first and my branch is lower in the alphabet. Carbon 4, carbon 5, carbon 6. So this becomes 3-ethyl, 3-ethyl dash 4-methyl hexane.